All right, so let me just get the course going. Just shoot over to screen share, but it's good to see all your faces. It motivates me to get going. So, all right, so I skipped over this. I finish off the coronavirus example. I will continue to try and bring in coronavirus as much as I can. Again, today we'll be looking at the studies related to that drug that was being pushed, chloroquine. We'll look at some studies related to that and media reporting on that. But someone asked me about this picture here that I jumped over, and what is big data? Companies like Google and eBay and Twitter and Facebook are collecting massive amounts of data on you and on what we do. They're collecting massive amounts of data, but they're only on their own population. They really of customers, of users, and they're not really reflective of their data on the entire population, say of the US population. Not everyone's on Twitter, not everyone's on Facebook. And so therefore, in terms of trying to make inferences from big data, you might have massive amounts of data, but it's really only useful within your own ecosystem, is the way to think of it. And it can't really extrapolate, is the word for it, beyond, make inferences beyond your own ecosystem of data. It doesn't do that for you. Where a random sample is extremely powerful is that if you can collect random data, you can really get close to the truth in the population, in very large populations. That's what intrigued me about statistics when I first started in college. You knew it was a branch of mathematics, it was something to do with mathematics. You knew it was applied mathematics to some degree, but I enjoyed mathematics in high school, and then I was just deciding what I'm going to do. And so basically I went into a stats class. And one of the first things he said, that how close a sample gets to the truth in the population mean cholesterol level, some population characteristic, is all sample size driven. It's not anything to do with the size of the population. The population size could be 1 million, 10 million, 100 million, 1 billion. The same sample size will get you as close to the true population characteristic that you're interested in, no matter what the population size is. And so there's the core of statistics, we'll see today, the random sample as a way of getting us close to the truth in the population, no matter what size the population is, versus random assignment, where we randomly assign people to 2 drugs, which we'll talk about in a minute, which allows us to make causal conclusions about the effectiveness of drugs. Otherwise, we could not do it. And so random sampling and random assignment are 2 very powerful mechanisms. And so all I was trying to show here is not the best analogy, is that, yes, you guess it's the Mona Lisa, so maybe I should have picked something that was a bit more less known. What I'm saying is we're trying to get a sense of the big picture in the world around us, in populations of interest. The truth is unknowable infinitely, absolutely. We pursue that truth with data. We collect a sample of data. But a random sample, the power of it is, say you had millions of pixels for a picture, and you select a random sample of pixels. A random sample of pixels should be evenly distributed around the bigger picture. And so should give us a sense of what the bigger picture is. And that's really where I'm trying to go with the analogy, is that the power of a random sample, it will be representative of the picture. And in this analogy, its pixels should be evenly spread around the picture to give us a clear sense of the picture. Whereas you could have a lot more pixels, data. Say maybe you have hundreds of thousands of pixels instead of maybe whatever is here, maybe only 1,000. Maybe you have hundreds of thousands of pixels, and so you have a density of them here, but you don't know what the picture is. To be honest, with big data, it would not be so clear cut. You wouldn't have pieces of the picture. It'd be all the pixels would be intermingled, and it would make no sense. So my point is the power of a random sample to give you a sense of the picture, whereas you may have a lot of data, but if it's not random, it wouldn't give you a clear sense of the bigger picture. So let's move along. I want to get through what we're talking about here, is that we all agree that this is inflated. It was based on going into supermarkets. At least the study on May 4th was, and we all agreed that's a convenient sample. It's not a random sample. Just by comparing 20% of 8 million New Yorkers is 1.6 million. And at that time, on May 20th, it was said in New York City there was only 200,000 people that actually had COVID. But we know that's underestimate, and this is an overestimate. So the truth is somewhere in between. So back to the random sample. If they could take a proper random sample from the population of New Yorkers and go and visit them in their home and and if you have to, if they don't leave the house, which a lot of people haven't, get all those people in your random sample. If you took 1,000 people, you get within 3% of the true rate of infection. But if you took 4,000, you'd get within 1.5% of the truth. Yeah, so the power of random samples is really what we're saying here. If you can take the time to get it, and I think they should try. I know Andrew Cuomo, Governor Cuomo, is one of the leaders in being driven by facts and data decision making, and that's good to see. But there's good statistics and there's bad statistics, and these are good statistics, meaning they're not the truth, because there's false positive, false negatives, systematic errors in measuring. They say they measure most people, but maybe they didn't measure everyone. But they're pretty much close to the truth. This is not close to the truth. So I got something in the chat here. I'm not sure what you mean. If everyone who is...
Hi, sorry, that was not clear at all. What I was trying to ask was, there are definitely people who have had coronavirus who haven't been able to access a test or get tested. And so they aren't necessarily included in this count of people, when there are statistics out about like how many people have been diagnosed, certain people haven't even been tested. So is that something that would increase, if that makes any sense? I don't know.
Yeah, it does make sense. Yes, we know this is a major underestimate. This is the number that they say had it, because so many people have not probably had it and not been tested. The statistic from the CDC of 35% of people being asymptomatic is probably pretty accurate from what they've seen already of cases across the board and demographics. Therefore, you have this huge number of people that may have had it. Maybe I've had it. I don't know. It can be so mild. Maybe you've had it. It's so mild and you don't know it. That's the frightening thing about this virus, is because of the fact so many people walking around feel innocent, and that's what I think caused it to take off. Is because tourists were coming over from Europe and they were infected, and they weren't staying in hotels because it wasn't like a flu. They didn't feel sick. But yeah, so that number is definitely way under. But I do feel that this number is a way over. So it's somewhere in between. We don't know. And what I'm saying is, if we did a properly selected random sample and tested all those people, and say 4,000 people out of the population of New Yorkers, we would get within 1.5% of the truth. And then at least we'd know within a certain margin of error that we're pretty close to the truth. And that's the power of a random sample and doing statistics properly, not just going into supermarkets and testing them there. So like the government, like Cuomo, anyways, he's coming a long way. It's great. He's better than other people just trusting their gut. You don't trust your gut with this. That's subjective thinking. This is all about objective reasoning for the whole, for everybody. What's good for you is not necessarily good for the whole. Subjective, you can believe and think what you like as long as you're not affecting anybody else. This is not about gut. This is about science and data, because it's about everybody. It's not about you. So yeah, but it's great to see Cuomo at least being driven by the data. But that's why everyone needs a statistical thinking course, because you need to kind of get these basics down.